All right, guys, so this video is going to be quick and it's just going to be a reminder of how to calculate molar volume from involving gas volumes and reactants, because reactants can be in the gaseous state. So as we said, that every time you have a reaction, the only language a reaction can speak is mole language. So if you have a volume or a value for a gas or an amount expressed as a volume, you need to be able to convert it back to moles and vice versa. So the keywords we're looking at are volume of a gas, molar volume of a gas, cubic centimeters, decimeter cubed, conversion factor, and RTP. RTP means room temperature and pressure, which means it could be 25 or sometimes taken as 20, but the pressure would be 1 atmospheric pressure. Cubic centimeters is the same equivalent as milliliters, and decimeter cubed is the same equivalent as liters. And really, these elements, for example, chlorine and hydrogen, are gaseous. Nitrogen dioxide is a brown gas, and therefore they will, if we have them at a specific temperature and pressure, they will occupy the same volume, and therefore we are going to use this in order to in our conversion factors. But before that, let's just recap on what the volume units are. So 1 liter is 1 decimeter cubed, which is 1,000 centimeters cubed. And 1 cubic centimeter is equivalent to a milliliter. Now, to convert between a decimeter and a centimeter, it's 1 decimeter is equivalent to 10. However, if you cube the decimeter, you are going to also cube the centimeter. So 1 decimeter cubed contains 1,000 cubic centimeters. Therefore, to go from decimeter to cubic centimeter, you multiply by 1,000. But if you're given the volume as in cubic centimeters, you divide by 1,000. So for example, here, if you have 50 cubic centimeters, if you divide by 1,000, it becomes in decimeter cubed. Okay, and that's it. So that's the conversion factor that you need to remember. Now, so yeah, if you like to use that staircase thing where it's between decimeter cubed and cubic centimeter, it's 10, but then you cube it because the 10 gets cubed and it becomes 1,000. Going down, you multiply, going up, you divide. And the concept's very easy. You have to remember that 1 mole of a gas occupies 24 cubic decimeters. So now every time you use this conversion factor, you're going to write whatever is given underneath it, like matching units, and then you will cross multiply. For example, let's say that you have 0.2 moles of a gas, any gas, like here, for example, carbon dioxide at RTP. What is its molar volume? Therefore, you would say that the conversion factor, 1 mole contains 24 decimeter cubed volume of a gas. If I had 0.2 of it, how much volume would that mean? By cross multiplication, 0.2 times 24 over 1, and therefore you're going to see here 0.2 times 24 over 1. The units here they cross out, and then you get your final answer in cubic decimeters. So simply like that. All you need to do is just align the units underneath each other. And another occasion, for example, here you have 120 cubic centimeters, and then you divide by 1,000 to convert it into centimeters cubed. How many moles would that make? So you will basically just put these underneath each other, and you will align the cubic decimeter units together here, and you will multiply by 1 divided by 24. So basically it's in pink over here, times 1 divided by 24. Your units will cancel out, and so you're going to have an answer in moles. Okay. Another example, for example, here, if you have 1 mole occupies 24, what if you have 2.4 decimeter cubed? You write it underneath it, cross multiply, so it becomes 1 times 2.4, 1 times 2.4 divided by 24, and then you get 0.4 moles. If you, same thing, if you just change, and it's good practice to actually write the moles of whatever you're calculating, like subscript. So N of O2 over here, N of O2, or if you're finding the volume, it would be V of O2. Okay, so keep always labeling with the symbol of whatever element you are calculating, or compound. Okay, it doesn't matter. So that's it for volume. Thank you so much.